In this video, we're going to look at some more factoring word problems. So the first one says the square of a number increased by twice the number is 48. So that would mean I square a number and then I increase it by twice that number, and that equals 48. So I'm going to solve for x here. So I'm going to set it equal to 0 by moving the 48 to the other side, and I'm going to factor. So I'm looking for the factors of 48 that add up to give me 2. So that would be negative 48. So it would be 6 and 8, and the 8 would have to be positive and the 6 would be negative. And then I would set each of these equal to 0 using the zero product property, and that would mean that x could be negative 8 or 6. In the second question, it says the shorter side of a rectangle is 3 less than the longer side. So if we call the longer side x, the shorter side is 3 less than that, and the area is 54. So if I do length times width, that would give me x squared minus 3x equals 54. And I'm going to set it equal to 0 so that I can factor and solve. So the factors of 54 that add up to give me negative 3 would be, it's negative 54, would give me negative 9 and positive 6. And if I set each of those equal to 0 using the zero product property, I get that x is either 9 or x is negative, or x is, because this would be plus 6, or x is negative 6, which negative 6 doesn't make sense. So it would have to be that the length were 9, or one dimension were 9, and the other dimension were 9 minus 3, which is 6. So the dimensions would be 9 and 6. In number 3, it says, what is the smallest of 3 consecutive positive integers if the product of the smaller two is 10 less than 10 times the largest? So remember back when we did consecutive integers, we would do like x and x plus 1 and x plus 2. It purposely says positive so that when we get our final answer, if there's a negative, we're only looking at the positive. So it says, to write the equation, I'm going to do the product of the smaller two is equal to 10 less than 10 times the larger one. So that would look like that, 10 less than 10 times the larger one. And if I simplify that, I get x squared plus x equals 10x plus 20 minus 10. So x squared plus x equals 10x plus 10. And I want to set it equal to 0, so I'm going to move the 10x over, which would give me a negative 9x, and the 10 over, which would give me negative 10. And I'm going to factor that. So the factors of negative 10 that add up to give me negative 9 would be negative 10 and positive 1. So if I set both of those equal to 0 using the zero product property, I get that either x is 10 or x is negative 1, but since it said positive, I'm going to go with 10. So the numbers would be 10, one of the smallest, so I just wanted x. Said what is the smallest of 3? So the answer is that x equals 10. Alright, number 4 says the larger leg of a right triangle, I'll draw a right triangle. The larger leg of the right triangle is 2 centimeters longer than its smaller leg. So if we call x 2 centimeters longer would be x plus 2, and the hypotenuse is 4 centimeters longer than the smaller, so x plus 4. So if we want to think about this using the Pythagorean theorem, we would do x squared plus x plus 2 squared equals x plus 4 squared. And so remember, when we square a binomial, we have to remember that means to multiply it by itself, not just to square each term. So that's going to give us x squared, and this would be x squared plus 2x plus 2x plus 4 equals x squared plus 4x plus 4x plus 16. So we could simplify this side to be 2x squared plus 4x plus 4 equals x squared plus 8x plus 16. But I want it equal to 0 so that I can solve it. So I'm going to subtract each of these things to the other side. So that would 2x squared minus x squared would just be x squared. 4x minus 8x would be negative 4x. And 4 minus 16 would be negative 12. And then we'll factor that. So the factors of negative 12 that add up to give me negative 4 would be negative 6 and positive 2. And if we set each of those equal to 0, we get either x is 6 or x is negative 2, but it doesn't make sense for it to be 6. So the smaller leg is 6. So here's an example for you to solve. So first you're going to write the equation to model the situation, and then in the free response you're going to actually solve it so that you can list the positive solution.